Hello. Guys, in our understanding of data, we will understand what really data is and how it is connected. And this is under the topic of Unit 1 of our KX 601, that is source and nature of the data. Fundamentally, we need to understand which type of data are there and how data are collected. We know that there are data is a raw facts only, and how these data are collected and how they are categorized, we will understand in this PPT. Okay. Now, fundamentally, there are two types of data. Quantitative data, that are numbers, tests, counting, measuring, etc. Okay. Second type is qualitative. Words, images, observations, conversations, photographs. These types of data are known as qualitative data. Next, we have a data collection techniques. How the data collection techniques works? Data collection techniques has many different sources. We have observations, we have tests, we have surveys, we have document analysis, and which is through the research literature. Usually, we will understand in our next video. Then we have quantitative methods. In the quantitative methods, how we will get our data? We will get our data through experiment. We create a research situation with at least one independent variable which is manipulated by the researchers. Okay, then we will with help of this experiment and by putting the mean of putting a methods in it, we will get our data. What is meaning of independent variable for manipulating this method? The independent variable, the variable in the study under consideration, the cost for the outcome for the study. So what really the independent is? Independent is the variable in the study under consideration, the cost for the outcome of for the study. And what are the dependent variables? The variable being affected by the independent variables, the effect of the study. So in general, which we need to understand, it is if it is a y is equal to fx. So what do you think? What is the way there, dependent or independent? As we understand, this function shows that the function of x is whatever changes x will be, it will be reflected in the y. So independent variable is the variable in the study under consideration. So x, whenever we change the value of the x, we'll get the value of the y will change. This is a cause, the outcome of for the study. So y is equal to fx. Okay, y is equal to fx. So which is which here? So fx will be your dependent variable and y will be your independent variable. So sorry, x will be independent variable and y will be a dependent variable. Now, when we say we need to define the method, what are the key factors for the high quality experiment design? So first and foremost is data should not be contaminated by the poor measurements or error in procedure. Second, eliminate the confounding variables from the study or minimize effects on the variable. Confounding intermixing things. Third, representativeness. Does your sample represent the population you are studying? Must use sample random techniques. What makes quantitative research design? There are four main key elements. First, freedom from the bias. Our quantitative design should be freedom from the bias. Our, content, our, our quantitative research design should be freedom from the confound. And third is control of extraneous variables. And fourth is statistical precision test hypothesis. Now, let's understand all those four variables. First is bias. When observation favors some individual in the population over others, it is known as bias. What is confounding? When the effects of the two or more variables cannot be separated. What is extraneous variable? Any variable that has an effect on the dependent variable is known as extraneous variable. We need to identify and minimize these variables. Example, erosion potential as a function of a clay content when fall intensity, vegetation, and duration would be considered as variables. So we need to find a erosion potential as a function in the clay content. You know, if you made something object from the clay, in which time it will get eroded. So in this experiment, we need to take the consideration like rainfall intensity, vegetation, and duration as well. And it should be considered as extraneous variable to really understand the function of the clay content in a better way. Now, what is the precision versus accuracy? Precise means sharply defined or measured. Accurate means truthful or correct. Okay. So, well, what is really the precise? Precise is sharply defined or measured. Accurate means truthful or correct. So, precision versus accuracy. What really the precision is? In the precision, we will understand it by the four dart figures. The red block is this red one is showing this red one. There is a red block, this one. This red block is actually all is getting all three darts. So all three darts are accurate as well on the precision, but is on the target actually, which is our target. It's target. Now, in the second condition, only one of our dart arrow is on a target. So it is accurate. We are getting accurate result, but it's not very precise. Now, seeing this condition, we are not getting any target on our fixed location, not any target. So all the three darts are neither accurate or not precise. Here also, all the three darts are we are not getting at the our main aim. So here also it is not accurate and not precise. Okay. So I hope you understand what is really the difference between accuracy and precision. Let's move ahead with this knowledge. Now, what will be the interpreting results of the experiments? Here, in any research, the goal of research is to draw conclusions. What did the study means? What, if any, cause and effect in the outcome? Now, why I'm going to these topics? We are going to three topics to really have an understanding how we conduct our research with the statistical computation, because it will help us in the further understanding of the algorithms what we have in our syllabus. And now, what is really a sampling is all about? Sampling basically used to study the population of our target. Sampling is the problem of accurately acquiring the necessary data in order to form a representative view of the problem. This is much more difficult to do than in general realized. Okay. So in general, for getting any experimental data, what really we need a objective from which we'll conduct a survey, and in the survey we'll define our target population, define the data to be collected, and we will define the variables to be determined. Then we will go for the required precision and accuracy. Then we will define the measurement instruments. Then we will define the sample size and sampling method. Then we select the sample. Now, for sampling, understand this touch very much in general. If you, I'm going to give an example. First of all, we need to construct an objective. After objective is constructed, we'll go for some target population, and by going to by different means of the surveys and all, but we will get our data, and in the heap of the data we will define our variables which we need to determine, and after that we will get a required precision and accuracy. Then we go for defining the measuring instruments. Then we'll define those instruments in sample size and sampling method. Then we select that method. Not really what really the sampling method is all about. See, sampling method is a distribution. When you form a sample, it often shows the plotted distribution known as the histogram. Histogram is like this. A histogram is a distribution of the frequency of occurrence of the certain variables within a specified range, not a bar graph which looks very similar. It's really in the example of a histogram. We have a green size versus wheat percentage. Okay. Okay. So and this is the histogram actually. So interpreting quantitative findings. So for any interpretation of the quantitative findings, we go with the descriptive statistics. These are mean, median, mode, and frequencies and error analysis. What is mean? In the science, the term mean is really the arithmetic mean given by the equation x bar 1 by n, 1 to n x r, or more simply to put the sum of values divided by the values of the sum. So we have 1, 2, 3, 4. Then we will divide 1 plus 2 plus 3 plus 4. 3, 3, 6 plus 4. 10 divided by 4. Then we get our this mean value. What is median? Consider this example 1, 1, 2, 2, 3, 6, 7, 1, 11, 11, 13, 14, 16, 19. In this case, there are 13 values. So the median of is the middle value and plus 1 by 2. 13 plus 1 by 2, that is 7. Consider we said 1, 1, 2, 2, 3, 6, 7, 11, 11, 13, 14, 16. In the second case, the mean of the two values is the median of n plus 1 by 2. So here we will get 12 plus 1 by 2, 16 over 5. That is equal to the two variables. I know between the two values, 6 or 7. So or we simply put the mid value separating all the values upper half into the half is known as the median value. What is mode? Mode is a frequency actually. The most frequent value in a data set, considering a set 1, 1, 1, 1, 2, 2, 3, 6, 11, 11, 11, 13, 14, 16, 19. In this case, the mode is 1 because it is the most common value. There may be cases where there are more than one mode as an increase. Okay. So 1, 1, 1, 2, 2, 3, 6, 11, 11, 11, 11. So what is the frequency out here? So we are getting two mode 1, 1, 1, 4 times, 11, 11, 4 times. Okay, 2, 2, 2 times, 3, 6, 13, 14, 1 times. So we have bimodal 1 and 11. We have 4 time frequency in the data set. So finally, this is what a small introduction of the data and data collection. Okay. In the next lecture, we will really understand what are the sources and the nature of the data. Okay. Till then, enjoy your happy learning.